Okay. Fundamental theorem basic, example 1. Okay, so the problem is to compute this thing. Okay, remember this is dH dt. Let's say this is dH dt, so dH dt is t plus 2. Okay, so I'm going to solve this problem in 2 ways. So way 1 is to look at it in terms of area. Okay, this is the area below between t plus 2 from t equals 2 to t equals 3. Okay, so we're going to find how much area we have here. So we're going to find all of this, we're going to find the area of this funny shape here. I think this is called a trapezoid. Okay. So you can interpret this as an area, right? If this is, so this is dH dt, remember this is the change in h. Okay. So we can compute the change in h by computing this area here. Now we can look at this area as 2 different pieces. We can look at it as the area of the triangle. So as an area of a triangle, and the area of a rectangle. So we'll add the area of the triangle to the area of the rectangle, and that'll be our answer. Okay, so let's see, this will be the area of the triangle. I'll just write that in there. Plus area rectangle. Okay, the area of the triangle, let's see, we have 1/2 the base. Now the base is this length here. That's 3 minus 2, or 1, times 1 times the height. All right, so remember that I found to figure out how high to go up at 2, you have to plug it into the function. 2 plus 2 is 4. How high to go up at 3? 3 plus 2 is 5. That's how we get that height there. Okay, so the height is 5 minus 4, or 1. Now the area of the rectangle, length times width. Let's see, the width is 1, and the length, or height, is 4. So my answer is 1/2 plus 4. 4.5, or 4.5. Okay. All right, so that's one way to do it. We can interpret it graphically and find the area there. Now this only works when we have straight lines. When we have curvy lines, it's hard to tell the area there. Okay. All right, so we got this to be 4.5. Let me put that in there. Just 4.5, and we'll verify that it works this other way. Okay, another way is to find an antiderivative, or the general antiderivative. Okay, so remember that h prime of t is dH dt, which in this case is t plus 2. Now we'll find the antiderivative, h of t, t squared over 2 plus 2t plus c. And now we can check our work. We take the derivative, the 2 comes down, those cancel, we go back to a t and a 2. Constant, the derivative of constant is always 0. Okay, So step 1, we find the antiderivative. Step 2, evaluate the endpoints. So h of 3 minus h of 2. Okay, let's see, this is going to be 3 squared over 2 plus 2 times 3 plus c minus h of 2. Let's see, h of 2, let's see, that's 2 squared over 2 plus 2 times 2 plus c. All right, so we got 9 over 2 plus 6 plus c minus 4 over 2. Oops, there we go. It's got me there. Plus 4 plus c. So let's see, that's 9 over 2 is 4.5 plus 6 plus c minus, let's see, this is going to be a 2, right? So you got 2 plus 4 plus c. Let's see, 2 plus 4 plus c, that's 6 plus c, right? So that's a 6 there. So you can see what happens, right? You get 4.5 plus 6 plus c. Distributing that negative, we get minus 6 minus c. So again, we get 4.5. So you can see that it works.